This is COP402, the idea on cloud governance. Thank you very much for being here. Please remember at the end of the session, complete the survey, unless you forget. Welcome once more. So let's start with imagining a scenario. Let's say that you have a call from your CFO telling you that your cost has been skyrocketed for the past few months, and no one knows why. You also have a call from your security team that looks like there are some unencrypted S3 buckets that just expose sensitive data. Probably this sounds familiar for some of you, and unfortunately, it's also the case for many organizations that don't have governance built in within their cloud strategy. Now, what happens with this is that it is not a matter of what you can build in today's dynamic environment, but also how you can manage those environments without losing the agility that brought you to AWS in the first place. Now, by the end of this session, you will have the tools and processes to actually automate compliance and for an environment to stay secure and govern your AWS resources. And we can see how that looks at the end to have a deep dive on cloud governance. My name is Rodolfo Brenes. I'm a principal solutions architect. And today with me co-presenting is Mateos Reyes, also a senior solutions architect on the same team, focused on governance and compliance. And we welcome you once more to the session today. Now, what is cloud governance? Cloud governance, it depends on who you ask. For some folks, it could be security. For other ones, it could be cost management, operations. But at the end of the day, cloud governance is a framework. It's a set of rules, processes that helps you align your AWS usage to your business objectives. But it's not just a static set of rules. It is a strategic approach on how you can manage your cloud resources effectively and secure. Now, let's take a look on how. What we see our customers focus the most or having challenges at the beginning are these three main things. The first one is scalability. How you can ensure that your governance policies and practices are growing alongside your AWS or your cloud infrastructure. How you can efficiently actually manage those costs and resources at scale. The second one is security. How you can protect your sensitive data and your infrastructure on your organization. And how you can be compliant and follow industry regulations in your AWS environment. And the third one is how you can automate and integrate with the multiple services that you may be using. How you can actually enforce those controls at scale by reducing human error. How you can actually have alerts and remediations in case if needed. How you can actually automate that and reduce that human error. Those are the three main things. Now, taking all of that into consideration, we need to start mapping those business needs we talked at the beginning to our actually AWS resources. The first thing that we recommend from a technical perspective is taking a look into your account strategy. Of course, because this will help you implement this multi-account setup to effectively isolate your workloads, manage things like limits, and isolate, for example, manage access and optimize your ability. And of course, allows you to enable consistently those policies across your organization. The second one is controls. How do you actually establish your guardrails and practices for governance to stay secure and operate efficiently? And how you can actually follow those compliance needs and those security standards? And how you can have a strong identity management, ensure that you're leveraging least privilege, for example. And the third one is auditing. How you can provide assurance that you are actually doing all those mitigations, that you're applying all those controls. And in case if needed, how you can actually remediate those automatically in case you need to support, as I mentioned, like forensic investigation and so on. How you can actually have almost real-time monitoring on top of it. And that goes towards auditing. Now, let's start talking about account strategy as the first one. One of the key things that we want to cover is AWS organizations integration. So this actually allows customers. The reason that is so important is because it allows customers to actually leverage those key features that they might be already using on a specific AWS service to actually have those applicable at scale. And here we're seeing these four pillars of all the services integrations that we have in AWS organizations. Let's take into an example. For example, customers might be using Security Hub to take advantage of all those security checks following specific security standards on a single account. Now with AWS organizations integration, they can have centrally a single pane of glass for those needs. So that's one example. But let's walk through step by step on normal scenarios. Like we have one specific user that's starting with an scenario for a standalone account. He starts with one account, he starts deploying resources, everything goes fine. They are very happy with what they're getting from their business objectives, but then they decided to do some cost management. So they say, okay, I have one single account. I go ahead and I found out that we have Cost Optimization Hub. It's a service that it will gives you optimization recommendations, things like you need to get a savings plan, a reserve instance. Is there a new generation of compute that it might be more cost efficient for them? So they start looking to the recommendations and they reduce the costs. They are running more efficiently, so they're happy with that. So they keep growing because they are now being more optimized. So the AWS footprint keeps getting bigger. The thing with this is that now they have 3 accounts. The same end user, they need to assume 3 different roles on each account, get to the recommendations on Cost Optimization Hub, and they start seeing the value, but now they are starting to grow more and more. As things gets growing, this could be 3 accounts, 6 accounts, 9 accounts, hundreds of accounts, thousands of accounts. This start getting complicated for them. So now they still need to do the same thing. They need to log into a single account, 2 more roles going into it. Of course not. And this is when AWS organizations help you scale. So taking advantage of these integrations, they can leverage the same service, but to have a central view, an organizational view from a management account, or as best practices are applicable in here, you can leverage a delegated administrator account. With this one, you avoid to give your end users access to the management account, so this way you have segregation of duties and you enforce least privilege, so they can log into their account for cost management. That could be the delegated administrator account that has the proper permissions that they need to actually look at the recommendations without actually going into the management. This is very powerful because, of course, it allows them to scale, but enforcing security, for example, in this case. But this is a journey. So to guide us through that journey of account strategy and the evolution, we have Mateos with us.
Of course. So let's talk about account strategy evolution. So we understand that multi-account strategy, it is a journey. It is not something that you set once and then forget about it. So I recommend everyone to check it out, that white paper right there. This is a set of recommendation, best practice, and also recommendation design of organization units that we have. It is important to understand that this white paper is not something set in stone. We understand that each customer, each company will have their own design. But that white paper as well also have the recommendations of successful customers that we've been seeing acquire these many years that we have with AWS organization, that they were able to be successful using AWS organization. So one of them, it is right there. So foundational OU, you have 2 OUs over there. You see the security OU, which usually it is for accounts for logging, auditing, backup. Those are the accounts that should be under the security OU. Sandbox OU, the infrastructure OU, also on the foundation OU, it is accounts that you're going to have like networking, identity, things like that. You see that. So those customers, and also the recommendation that we have in that white paper, we are able to see all of that. They deploy those OUs in order to centralize their management. We also have Sandbox OU for streamline testing new features. AWS launch every single new stuff every single day. So you should reduce the scope of those accounts under that Sandbox OU. Make sure that doesn't have connectivity with your on-premise and things like that for testing purpose. And of course, you have the workloads, your applications, right? So we recommend to have a parent OU, in that case, the workloads OU, and also the non-production, production, whatever the name that you have, under that workload OU to make sure to leverage the AWS organization services like SCPs and RCPs that we're going to cover in a second. So by establishing this parental level, you can inherit all the policies for the other organization unit underneath that particular one. So this is an evolution, right? So you started with that, and then you move on to another ones. Now you added like suspended OU or transitional OU. So suspended OU, it is make sure that you move accounts that you close to that OU. Why? Because account with AWS, it is only closed after 90 days. So make sure that nobody's going to be open that account if that is that on that suspended OU. And of course, you're going to also make sure to have the boundaries to secure that nobody can reopen their accounts. You can also have transitional OU. So for merchant acquisitions, for instance, if you're dealing with a lot of merchant acquisition and you don't know exactly where this account from organization 1 is going to be migrated to organization 2, you don't know exactly where this account is going to arrive, put it in the transition OU and you can figure it out later. Put some security boundaries first to make sure that only the default, you have that, then you do the transition after that. So very useful for merchant acquisitions. Last one, it is now you have a bigger picture. You are adding more adding more accounts. Again, we're talking about scaling over here, right? So, which was one of the first challenges that Rodolfo mentioned before. Now you have another set of OUs. So in this case, exceptional OUs will be for accounts that is like exception, right? They will be lower the security standards that you have under the OU. With the caution, this should be temporary, okay? Exceptional use should be first of all with a limited number of accounts and also limited number of time that you have those accounts on that exceptional OU as well. Establishing that process will guarantee that you follow a best practice. Policy staging are used, so in order to test it out, for instance, SCPs, service control policies, which are very powerful, you cannot test it, that is not a native way that you can test it as of today. So we recommended you to have OU so you can test it out before you apply to the target OU. Because if you make it some mistake or if you didn't code that right, unfortunately, it can be very disruptive. So why not having a policy staged, test it out first, and then you move along to the target OU as well. Last one, it is business continuity. Very useful for disaster recovery. So make sure that you have the IAM roles, only the people assigned to that matter, to disaster recovery, assigned to those accounts under that business continuity OU, and you can leverage that with this example right here. Now, our recommendation in order to build that up, it is AWS Control Tower. So AWS Control Tower, it is a managed service that you can help with multi-account setup, following best practice, deploying a landing zone. You can create accounts through it, integrates with more than 14 foundation servers, as you can see in the screen, AWS organizations, Identity Center, CloudTrail, config, and so on. You're going to deploy a log archive account under the security OU, where you're going to have an S3 bucket with the CloudTrail logs and also config logs centralized. You're going to deploy an audit account as well with config enable across the board to all your accounts. So independently, if you are already in the journey with AWS, your multi-account strategy, we do recommend that you deploy AWS Control Tower to centralize controls management. And you can also create accounts under that sandbox accounts as an optional. You can create more, but as an option, you can create provisioning accounts using account factories. And guess what? All the accounts that will be created by this account factor will be born with all the standards that you deploy, all the account baseline, all the controls that you deploy. The AWS Control Tower as of today has more than 500 managed controls that you can deploy across the board by organization unit level. We recently announced in the middle integration with AWS Backup. So under Security OU right now, you're going to be asked if you wanted to integrate with AWS Backup, 2 new accounts: central backup account where you're going to have all your vaults, and backup administrator account where you're going to oversee your AWS backup. I'm talking about the policies, the audit manager under that, which type of research that you're going to do AWS backup. So we launched this last week. So today is Monday, so we launched that last week. So check it out. So following also the same recommendations as I mentioned before. But if AWS Control Tower itself doesn't fit in all your needs and you still wanted to make sure to streamline account vending, you should take a look at the lifecycle events. So lifecycle events, it is a way to get events after an account creation. So in this case, I'm here in the management account, creating my account via AWS Control Tower. And at the moment that this new account is vended with all the best practice, all the things that you deploy using the AWS Control Tower, you can get that event using an event bridge. And because I can get that, I can trigger, for instance, a Lambda or I can trigger even a CloudFormation stack set that will trigger account customizations towards the new vended account. Like for instance, IAM roles, like VPC flow logs that I might need, or even the Lambda itself can trigger directly customization in this new vended account. For instance, enabling a guard duty, make sure that security hub is enabled across the board and sending authorization to the delegated account that Rodolfo mentioned before. So this is something that you can leverage across the boards. Using lifecycle events, you can customize all the new vended accounts to have the same standard, to have the same blueprint of your security and governance needs. We recommend as well to take a look on the SRA, AWS SRA, Security Reference Architecture. It's a prescriptive guidance for the security service integrations that we have. It does integrate with AWS Control Tower, so it is very easy to deploy that template and have all the service enabling, logging, so on and so forth, all the things that we mentioned so far, you have that in that SRA. Okay, great. So we talk about account strategy. Now it's time to talk about controls, right? Like Rodolfo mentioned, control is a key important piece of governance. So what is exactly it is control? So everything starts with the policy. So a policy is a document that states the expectations of your company, of your customers about a particular regulatory situation. Then you have the controls objective on top of the policy, which will be the targets towards that policy. And then you have the standards on top of that. Like I wanted to make sure that I'm in NIST compliance or PCI compliance. This is a formal requirements to a control objective. And the last but not least is the security control itself, where I have the mechanisms to put in place and implement the standards. So controls are mapped to standards, then to an objective, and finally to the policy intention. That's the pyramid for the governance as a whole in terms of controls. AWS has 3 types of controls that you can implement: preventive, proactive, and detective. We're going to start talking about prevention first, preventive controls. So preventive controls are security controls that is designed to prevent an event from occurring, and so beforehand. This is a well-known control as a first line of defense to help prevent unauthorized access or one-on-one people access to your network. The way that you do this on AWS organizations have authorization policy, SCPs, like we mentioned before. This is a very well-known service control policy. And if you are catching up our launches, we launched a couple weeks ago RCPs, Resource Control Policy. Those policies, those controls are not giving permission. First of all, they are not giving permission. They are making sure to allow and set the maximum of permission to an identity or to a resource in this case. So let's take a look specifically for RCP, how was before this launch that we did it a couple of weeks ago. So RCPs, it's not that new, right? You guys are probably implemented resource policy every single day. For instance, S3 bucket. S3 bucket is our RCP. It is a resource policy. SQS policy, KMS policy, those are all resource policy. RCPs give you the capability to bring up the level up. So before RCPs, if I wanted to implement this bucket policy, in this case, I'm denying any actions of this particular S3 of someone outside of my organization, or if the principal is not a principal of an AWS service. That's the policy over there on the right. I needed to implement this in every single S3 that I have, in every single S3 bucket policy that I have across my regions and of course across my accounts. Now RCP gives the ability to you put the same policy. As you can see, it is the same policy right there, but now it is applicable at the higher level. So it will affect all the accounts, all the regions that contain an S3 bucket. It looks like, and it functions like the same as an SCP. If I'm attaching the RCP at the or hood level or the organization level, it will be required across the board, across the end level account. So in this case, that external threat actor will not be able to access any one of my S3 bucket. Even if I am an administrator that has permissions to change S3 bucket policy, because I have a permission at the higher level, it will be denied. Now, I know that some of you might have some sort of, okay, I don't quite understand yet how those things work with SCPs and RCPs. So first things first, SCPs and RCPs, they are independently controls, but they can also work together. Okay, you can apply to the hood level, organization unit level, nested organization unit, or even into account itself. RCPs are enforcing consistent access towards the resource that you have, rather than SCPs are looking for consistent access to the principles itself. So the use cases are a little bit different, but they can work together. So RCPs, if I wanted to make sure to no one going to have access to my resource externally, RCPs it is. Or if I wanted to make sure that I have enforced confused deputy controls, I can do that with RCPs. SCPs, it will prevent identity for access external resource. So make sure that I have all the access in my AWS organization. Or I wanted to make sure to prevent someone access a region that I don't have business. SCP is a proper way to do it. Let's take a look on an example right here. So when we talk about data perimeter, RCPs are very compelling over here, because in this case, RCPs are preventive non-corporate or external identity from access customer corporate resource. This is well known as identity perimeter. So RCPs, you include identity perimeter towards the RCPs, with RCPs. In the case of SCPs, I'm preventing corporate identity from access non-corporate or external resource. This is known as resource perimeter. So as you can see in the example right here, I can implement both at the same time, especially when I wanted to have an extra layer of data perimeter defense. So this is how RCP and SCP work together. But AWS organization also has managed policy. You guys already know, tag policy, backup, AI service opt-out, and we launched a couple weeks ago also chatbot policy. But if you are catching up our launch as well, we launched yesterday something called declarative policy. It's another preventive control that we launch, and this is how it looks like. So declarative policy launched with supporting EC2 and EC2 attributes like EBS, VPC. So those attributes we can now govern at the AWS organization level. So in this case, I can attach a policy to an organization unit that will block all the public sharing for EBS snapshot. With that, all the accounts and also all the regions will receive the same attribute, because that's why it's called declarative, because I'm declaring the state of that particular attribute that I want. In this case, blocking all the EBS snapshot to be shared. Not just the future ones, but also the existing snapshot will be blocked. They will not be able to block. So a few attributes you're going to see now with Rodolfo doing a demo, you will be able to do that. So Rodolfo, take it away.
Thank you, Mateus. All right. Okay. Well, let's take a look now on how those new policies and new type of preventative control actually work. We're going to start with resource control policies. As Mateus explained, this is a way for you to have some perimeter controls and some data perimeters on your AWS resources without actually going through SCPs or resource control policies. In this case, we're going to look at an example using Secrets Manager. For the ones that you know, Secrets Manager is a service that allows you to securely store your secrets. Could be passwords, could be access keys, those kind of things. In this case, just for the sake of the demo, let me see if I can make this a little bit bigger. I have one secret. This is my secret, no so secret because you are seeing it right now. Now, here that in this particular secret, I have an encryption key. This user have access to that one. I have a name. I have a resource name in this case. This is the secret ID for that matter. And then we have a secret value. If I retrieve the secret value, it's going to tell me that, yeah, the secret key is my secret. The value is very, very secret. Okay. Now, what we have in here is basically a resource policy, like the one that you saw for S3, the one that you normally probably already applied. This is telling me that, yeah, for this particular key or this particular secret, I have access from one particular account. In this case, this account is outside of my organization. Probably the developer was not too concerned about security. Maybe they were just doing some testing. They forgot. They just left the resource policy. This is basically given another role in another account the capability to get this secret. This is basically what this resource policy is doing right now. If secret, and I might log from that particular account, let's say that in here, all right, let's say that I want to, in this case, get the identity of this role that I'm assuming. It's going to tell me that I'm assuming that particular role that we saw in that other policy. If I need to get this secret, in this case, you're going to see that I'm leveraging the AWS CLI to get Secrets Manager, get secret value for a particular secret ID that lives on US East Region 1. Now, if I get this secret, it's going to let me know, yeah, this is my secret, very, very secret. This is the value of it. So I was able to actually access it from an account that lives outside my org. So we might need to establish some data perimeters. So this is when resource control policy comes into place. So let me switch to the actual organization's account. In this particular case, let me log into my management account. Here, this is the management account from my org. If we go to organizations, in this case, and we go to policies, we're going to see that now we have, besides declarative policies that we're going to look into it in a few minutes, if we go to resource control policies in this case, you're going to see that we already have two policies. The first one is RCP full AWS access. This is basically allowing me to perform actions. This is the same as we have in service control policies. It behaves exactly the same. You can attach these to organizational units, to AWS accounts. It's the same with RCPs. In this case, we have the full access that is basically allowing me to work. And then I can have specific actions. In this case, let's take a look on the secrets RCP policy. Now, this is following the same syntax that you are all familiar with. In this particular case, it's telling me that I'm having a deny effect on specific actions. In this case, all actions, right? So I'm not going to be able to perform any actions on this particular key that we just saw, right? The condition here, as we saw, we're establishing a perimeter on my organization. So if the request is coming from an organization ID that is not my current org, I'm basically going to deny it if it is not also a particular service from outside my organization. So this is the policy. If we go to targets in this case, we can see that we don't have any targets in here. If we decided, okay, let's attach it, I'm going to attach this to my secondary account. Basically, now I'm enforcing, regardless of the resource policy that we saw in the other account. Now, if we go to the terminal, I'm still in the same account. If I try to get the value on this one, now it's telling me that now I was denied because there is an explicit deny on my resource control policy. So now we have these developers or these individual members applying the resources that they want to, they're deploying the infrastructure that they need, and regardless if they miss something in terms of security, now you can enforce these centrally. So of course, allows you to focusing on innovation and being less concerned about those poor practices that we have. Now, let's move on into declarative policies. So let's take a look on how that looks. But first, let me show you something here. Let me switch to another account. So in this case, let's take a look on EC2. Remember that we mentioned that declarative policies at launch from yesterday. Now we're supporting attributes for EC2. So this is the service that at launch is being supported by declarative policies. And what we're trying to do is basically, enforce a specific baseline that I want all my resources to follow. Now, if we go in this particular case, let's go into the snapshots. We're going to see that I have already a snapshot created. Here, if I go into modifier permissions, you're going to see that this particular snapshot is a private one. If I go in here, I have the permissions, I just want to make it public, I can do it. There's nothing stopping me from doing that. I just go ahead and modify permissions, and that's it. From a management perspective, from a governance standpoint, how can I avoid that centrally without actually going and enforce all these actions and limiting this from identity perspective like we do it on service control policy? How can I do it from declarative policies these days? So let's go back into my management account. Okay, so if we go into my AWS organization again, and we go into policies, and we say, okay, let's take a look on these new declarative policies for EC2. In this case, I already have one. We're going to cover that one. This is basically disallowing the possibility for members or users to actually make my snapshots public. I want to disallow that. But let's take a look on how you actually can create a policy. You can just set a name. You can add a description. And here's the editor. This is the editor itself. So in this case, these are the attributes that we support at launch. These are for EC2. We support things like blocking public access to your snapshots, establishing a specific controls access. For example, VPC, public access, you can do that. So basically, regardless if you have an internet gateway created on your VPC, resources are not going to be able to communicate externally if you're actually disallowing this public access or this public connectivity within your VPC from a declarative policy standpoint. If we go to instance metadata defaults, for example, I want to enforce IMDS version 2 to have specific, let's say, token of authentication to my EC2 instances, right? I want to enforce instant metadata version 2. If I want to do that, I basically go ahead and say that the version, it has to have a token, it has to be version 2. If I want it to be optional, this means that it could be version 1. I can have that one. In this case, we're following that it has to be version 2 exactly. If I want to add some kind of error messages for the people that are leveraging, trying to get that, they get a friendly message, they can also do that. I can say, yeah, this is a test, for example, whatever, right? And I can just go ahead and do that. And I can establish more attributes if needed. Basically, in the same policy, I can start looking into this. All right? Let's take a look on the one that we already have. This one in particular is basically telling me that I'm blocking public access for my snapshots in every resource. The good thing with the current policies is now that you can enforce these for new resources or for all your resources, for example. And there's also a capability that is in here that allows you to have a status report of your resources, and you can put that onto an S3 bucket to make sure that your controls are not going to affect something that you don't want to affect. Right? So there is that now capability within declarative policies. Now, if we take a look and we actually go into targets and we do the same exercise, let's attach this and then say, okay, let's have it in the same account. And then if I go into my secondary account, the one that I was actually having that snapshot, in here, do the same. If I go to EC2, and I go to snapshots, and then say, okay, I'm the same guy trying to do the modify permissions. Okay, can I do it now? So here, if you scroll down, you're going to see that this option has been deactivated by the administrator of your account. So you cannot do this now. So this is very useful for you to, again, having the capability for you to centrally enforce those guardrails. All right. So back to you.
Thank you. Awesome. So we talk about preventive. Let's do proactive controls, right? We are talking about the controls. We talk about preventive. Let's go proactive. Proactive, it's about to check the compliance of the resource that is being deployed before the resource be actually deployed. So it determines whether the new resource will be complying with the controls that you have in place for your security and governance needs. And on AWS, you implement that using AWS CloudFormation hooks. CloudFormation hooks, it is a way to catch something in the middle of a CloudFormation template. Let's see an example right here. So I have this template. It is just an S3 bucket, very simple CloudFormation template with no properties whatsoever. And when I implement that, I do have a couple of hooks in place. And those hooks are also implemented something called CloudFormation Guard. CloudFormation Guard, it is a policy as a code solution tool that we have available, by the way, in GitHub. It is an open source. You can create rules to be, streamline your proactive controls. So this hook that I have is looking for S3 encryption. In that case, because I don't have anything, what's going to happen, the hook's going to be triggered, and because I have this particular guard looking for that, guess what? It will fail because there's no encryption whatsoever. Okay, but you can do this in CloudFormation. I'm more a Terraform person, or my company is deploying Terraform. Okay, now we can also have proactive controls implemented on AWS with Terraform. Something that we have called Cloud Control API, which is a standardized create, read, update, delete, and list APIs to manage all the service in an intuitive and capacity. We implement that with a new version or a new provider of Terraform called AWS CC, or AWS Cloud Control API. So if you use that AWS CC provider for your Terraform templates, guess what? What you can do? Let's take a look at an example. So you have your Terraform code. Again, very simple Terraform code that I have right here. I'm using AWS CC as my provider, and I wanted to deploy my S3 bucket. In this case, I have a hook looking for versioning. So AWS will translate Terraform to using SDK with Go to Cloud Control API, and Cloud Control API can be hooked up using CloudFormation hook. Because I have hook register, it will either pass or fail. So you can actually now use Terraform with AWS CC and proactive controls implemented by AWS. So let's see how that works. Okay, so I'm gonna change I already have a couple of things here, and the first thing that I wanted to share, it is the actual guard rule. So it's very straightforward. It's a DSL, so domain specific language type of service or a tool. In this case, I'm declaring or I'm established that all S3 resource, S3 buckets should have versioning enabled. So this is the guard, the rule itself. When I look into my Terraform template, this is how I have. This is what I have. So very simple Terraform template. So let's take a look on the CloudFormation and how I can establish that hook. So I'm going to create a hook. I believe it's better. I can now create a hook using guard directly, or a lambda. If you are looking for more granularity, lambda will be more appropriate, but you can also use guard. I already upload in my S3 bucket that rule that you guys saw it a couple minutes ago. I have output report. I can send that to the same bucket or another bucket, and I will pass the name of the hook itself, which in this case has 3 hooks, and the target will be Cloud Control API and also resource that I deploy. I wanted to do this at the creation and update, and the hook mode, which is very important, in this case will be failing because I wanted to stop the actions before it moves on. I'm going to create a new row. I can implement a filter if I want it. It's option by stacks or rows. I'm going to leave it as a default and activate the hook. Okay, great. So let's back to the terminal. I'm going to clear this up. What I'm going to do first, everybody knows, Terraform init. And I'm actually going to try to execute this. Say yes, I wanted to create the hook. And it fails, which is exactly what I was expecting. And because I have this information right here, I can get this and even take a look deeper results to the target type as cloud control with target ID as the one that you saw in above. What you're going to see is the full report will be in that S3 bucket that I shared before, but I can read that it fails because specifically the versioning, in this case right here, the version was not enabled. And that's exactly what I wanted. So now you can implement using AWS CC proactive controls on AWS as well, not just in CloudFormation. Before I back to Rodolfo, I wanted to just share, of course, a QR code that you're going to see a bunch of guard rules. This one was one example, but that QR code has a repo that has many rules applied to different type of resource as well. Back to you.
All right. Thank you, Mateus. Okay, so I already went through all the kind of mechanisms that you can enforce to have your controls from a preventive standpoint or from a proactive standpoint. But you never know, or something could happen. You can have an issue where you actually deployed a resource that went out of compliance. You still want to have the proper mechanisms to have the visibility if something like that happens. So it is also important that you have safeguard for detection and, of course, remediation of those resources. Now, you can leverage this leveraging a service that is AWS Config. Probably you are already very familiar with that. So let's take a look on how AWS Config can apply to a specific scenario for you to have detective mechanisms and controls. The first one is that you are able to track the configuration history of your resources through basically from two ways. The first one is event-based, that is basically every single time there is a resource and there is a change on that resource type, is going to generate what is called a configuration item, and based on that, you can run a specific evaluation. Or you can have periodic recording, let's say every 24 hours. You want to check a specific configuration state of one of your resources. Everything of this, it gets aggregated on what we call a configuration record. It's basically that particular service, AWS Config, taking advantage of the visibility that it has for all the AWS resources and keeping track of those changes. Once you have that, you have the capability for you to run evaluations. This is the evaluation of a desired state of your resources. It could be multiple things, and we're going to look into it. But once you run a config rule that could be checking, for example, versioning, as Mateus was explaining the proactive controls. So I want to check if those are actually being applied. I want a history of those in time, let's say, from the past few months, for the past months. All those kind of things, I can run these evaluations on config rules and have this as a compliance state, let's say, status. I evaluate this, and it's telling me, okay, this is the desired state, this is what you expect to have on this particular resource, so you're complying, you're following your own policies. So this is the capability for you to have these detective mechanisms. What happens if something is not compliant? Well, you can have that reported, and you can have manual, let's say, fixing on it, but you can also run automations, and you can leverage AWS System Manager with documents for you to run automations that could be built on your own, or can you use leverage you can use manage config, System Manager config auto remediations to actually put this back on your desired state. This is very powerful, and let's take a look on how this actually works. Now, keep in mind that config keeps the state of your resources, right? And it gives you a configuration item that is basically a JSON representation of your resources. This is the metadata of your resource. Now, in this particular case, we have an example of an EC2. As you can see, this is a JSON file. It's basically giving you all the value key pairs of the metadata of your resource. In this particular case, it's giving me the availability zone, it's giving me the region, the ID of that resource. If we continue and we scroll down and we dive deeper into the configuration option of this EC2 instance, we're going to see that, remember the instance metadata that we were talking about, declarative policies? Now it's telling me that, yeah, HTTP tokens are required. This is living into the metadata option of the configuration file of my EC2 instance. This is required. This is what I expect. Now, leveraging AWS config rules, in this particular case, I'm showing an example of Guard domain-specific language that was also covered by Mateos from a proactive standpoint, how you can have a CFN Guard hooks to actually enforce those proactively, but you can also leverage the same domain-specific language from config rules to create your own rules. Of course, AWS config also offers you a list of managed rules that are over 400, almost 500 rules, and you can leverage those for several use cases. But if there's something that you want to create, you can leverage Guard language to actually create those rules. You can also leverage Lambda. You can run those on Python if you want to get very specific, but also that requires for you to actually maintain the Lambdas and actually have that additional set of management responsibilities. In this case, if you leverage Guard within AWS config, it will take care of those kind of things. Now, this is a simple example. This is the checking just the metadata version of this particular EC2 instance. As we saw in the value key pairs of the JSON file of that particular EC2, I was looking into HTTP tokens that was living into, under metadata options under my configuration. In this case, I'm expecting a required value. That means that I'm enforcing version 2 as instance metadata for my versions. If not, I can just customize a message, error message. One of the key features for these custom rules, leveraging Guard, is that you can create CloudWatch log groups for you to run some troubleshooting if something is not working as expected. If you create a rule and you want to debug it, you can also create a specific log group for this particular custom rule that you created. How it looks, this is an example. As you can see here, this is basically telling me that that evaluation check that the config rule run is telling me that I was expecting a required value, but I'm getting optional. That means that I'm not running the proper version. So in this case, it's not following my policy, so I need to do something about it, right? Now, as we saw with the account evolution, the account strategy, a control tower was a managed service to get me started. It's the same thing that we have with controls. Control tower gives you a library of controls that are available to cover you on all three of these case scenarios that we saw. We have preventive use cases, we have detective use cases, and we have also proactive use cases. Now, keep in mind that at the beginning we mentioned that we were looking to align to our business objectives. In this case, of course, you are following the specific industry standards, so you are following your own, let's say, governance policies and strategies. In this case, instead of looking at the controls, we might start looking at what actually are the things that you want to accomplish. In this case, we're focusing on a service, let's say EC2. My objective is basically limit network access. I can do that from preventative use cases to dissolve, for example, access from a VPC. I can use proactive controls to make sure that the security groups are not providing more access that I'm expecting, and I can also have detective controls just to make sure that those are being applied. So in this case, I can leverage opinionated controls from Control Tower to establish that same business objectives, which is safely controls through internet access from AWS. This is an example of how you can leverage those managed solutions in order to achieve this. Now, the third category that we spoke at the beginning, from a technical perspective, was auditing. That's great. You have all these mechanisms. You have your multi-account strategy. You have all these things in place. You have all these controls. But then you need to provide assurance that you're actually applying this. How do you can do that? How do you actually can react? So that's the auditing piece. Now, the first thing is a service that you're very familiar now. This is AWS CloudTrail that gives you the capability for you to govern your audit trail. In this particular case, we're looking at the types of events that are supported for terms of trails for CloudTrail. It gives you the capability, for example, for you to create an organizational trail when you can aggregate all these events. In this case, if we look at management events, these are control plane events. Let's say from an S3 bucket perspective, if you create a new bucket, if you delete that bucket, those are control plane events that are tracked on the management and data event types. Management event types, I'm sorry. The other type is data events. If you are actually looking at the events that are incurring in your actual resource. The same case, following the same example with S3s, if you're actually deleting an object that lives under that S3 bucket. That is a type of data events. Those you need to create, those are not there by default, but there's also a price to that. So you need to be very careful, and there is a way for you to actually select which ones you want to track, and we'll look into that in a few seconds. And the third one is network activity events. This gives you the capability for actually you track the APIs that are flowing through your VPC endpoints. This was launched a few months ago. It's not that, it's fairly new. And it gives the capability for you to track the actual API calls that are being originated from your VPC. So it's a more granular, it gives you the capability for you to dive deeper into those audit trails that you need to look into. What is very critical and why CloudTrail events are so important is because it gives you that forensics capability to understand what is actually happening, those auditing needs that you may have. The first one is, of course, the event fields that are very important for you to know who did that, who made that call. You can leverage these events like user identity IRN, for example, user agent, these kind of things. Once you figured out who did it, you need to figure out what happened, right? What was actually changed? It was an account ID, where it was coming from, was the type of event name that you're specifying, where was the actual request parameters that are coming in that request. When that happened, of course, in time and region, you also need to track that one. And how? What was the vector that it was used to actually to perform that action? How you can look into that, for example, event type, what was the actual access keys that were leveraged, they were actually logging in through the console or not, those kind of things. How was that performed? And of course, you need to understand what was the result of it. Because it's important to, did it fail? It was a deny? It's not that bad, right? Somebody tried, but it was blocked. But what happens if they actually succeeded on it? So you need to understand that audit trail. Those are basic capabilities that you have to get. And of course, we start talking about, of course, how you can optimize these and monitor these actions. The first thing, in terms of optimizing, now we launched last week an enhanced event filtering capability for management and data events. So that means that you can actually avoid noisy type of, let's say, API calls from your specific CloudTrail lake. And CloudTrail lake is a way for you to hack and manage data lake on CloudTrail events. Without CloudTrail lake, for example, you could create your own, let's say, S3 buckets with all your logs, and you can run Athena queries on it, but you also need to take ownership of that management of that particular, let's say, lake that you were creating for CloudTrail events. You can also leverage CloudTrail lake, and you can optimize these to avoid specific resources from being, for example, very noisy or specific types of API calls that you identify. And we have highlights now and pre-built dashboards and custom dashboards that you can leverage to have that organizational view, and we're going to cover that one. Now, let's take a quick look on how those new advanced event collection filtering capabilities work. Basically, you can create your own lake and say, okay, I want to track everything, but I want to exclude a specific role that is making calls on behalf of a service that are very noisy, that I don't need to track in this particular use case. So I can do that. Is there any particular service event that I want to exclude in my CloudTrail lake? I can do that now with enhanced event filtering. In terms of visibility and having a way better way to have observability capabilities on auditing perspective, you can leverage the dashboard that are in place. We released last week Highlight Dashboard that is basically a way for you to have an activity overview. It's going to let you know the amount of accounts that you're leveraging, the activity on those accounts, any destructive actions that took in place, the regions that were actually being part of that audit trail. And now we also have the capability for you to have a summary powered by GenAI that gives you, in this case, it's telling me that I have this amount of throttling errors in the past 24 hours. This is the type of activity that I see in my account, so this is a highlight that we get. And we also have 14 pre-built dashboards. In this case, because we're focusing on governance, we have an organizational view. In this case, I'm trying to understand what are the most used services that I see across my organization. If I have how many accounts are actually being involved in this one, how many events were counted on those specific accounts, and and you can filter by date, and there are, as I mentioned, different types of dashboards. Of course, if this is not enough, you can also create your own dashboards. In this case, let's take a look on the top IAM APIs that I will leverage. I want to see the top 10 on my dashboard. I want to see S3 errors. I want to see I want to analyze error analysis. There are multiple widgets that you can leverage in order to create your own custom dashboard and increase the visibility that you might have in here. And to complete this picture, of course, you want to provide assurance. And remember that we mentioned at the beginning how you can actually follow industry standards and regulations. If you want to be, as possible, to audit ready for an external or internal audit. This service audit manager helps you with that automation. It allows you to actually automatically gather evidence from multiple sources like CloudTrail, as we saw, user activity logs, external evidence. If you want to upload something to a specific assessment, let's say a policy document that you want to upload that is not living on AWS, you can do that. Allows you to aggregate multiple services like AWS config checks or service-to-service API calls. Let's say that you want to take a snapshot of a particular resource to see how it's configured and allow that to be part of the evidence that on the assessment that you are running. So now you can share that with third-party tools or with your external auditing teams or even internals. Aggregates also with CloudTrail Lake to have just a quick check on the evidence through a query leveraging that technology. Now, let's go into key takeaways with Mateos for this.
Yeah, so it's time to wrap up. So few takeaways, key takeaways on this session that I wanted to you guys leave with the door. So first of all, make sure that you define your account strategy. Multi-account strategy is very important to governance, right? Take advantage of AWS Control Tower, deploy Control Tower, and also all the library that you have for those managed controls that we talk about. Second of all, take advantage and leverage the controls that support your governance objective. Like I said, Control Tower has 500 plus controls. I think also has a bunch of controls. Make sure to take advantage of that, and also AWS organization has capabilities for delegated admins to avoid someone having access into your management account. So use delegated admin to avoid that. Third one, automate. Leverage infrastructure as a code. And implement proactive controls. Make sure that you have those proactive controls to enforce shift left culture back to the developer, so they can take action upon it of that particular compliance. This is a few additional resources that I wanted to leave for you all. So there's a cloud adoption framework, and the first one that is IDC study that we interview 8 customers around the globe where they share how their migration product were able to help with AWS Cloud Governance Service. The third one, it is our principal page, AWS Cloud Governance principal page with all the resources that you have. This is a few recommended related sessions that you're gonna see here throughout the event. Today is only Monday, right? So COP402, we're gonna talk about config with Itaú. I'm gonna be there talking again for you guys. There is other other sessions that you can take a look at regarding governance itself. If you are not able to attend those sessions, take a look on the kiosk. We have a booth at the village with a VR experience. We have books, giveaways, we have swags. There is a specific booth for governance and compliance. So if you have questions, we're going to be there as a specialist, other specialists from AWS. Go there and check it out. So that is it. I wanted to, first of all, say thank you very much for being here in this session. Please don't forget to complete the survey for us, and have a great event. Thank you.